Hey everyone, it's Patrick from the Babylon.js team. Welcome back to the channel. Today I want to talk about how we can use audio in the engine and how we can easily load in some audio files, play them, advance to the next track, to the previous track, stop, and then we also want to do a really cool visualizer effect. And let me show you that right now. So this is the thing that we're going to make today. And this is kind of a complex project, so I'm going to split this into two videos. The first one is going to be about the visualization of the audio, and then the second one is going to be about the control panel that we've got going here with the animations and the buttons. But this is what it looks like. So we've got some sound loading in. I am playing the track, and we're using the analyzer in the Babylon audio engine to extract the levels for the 16 bands that we've created for this equalizer, and we're piping it right into a node material. And so we're using that data from the analyzer to drive the height of the lights in the node material that's just applied to a plane. So it's a pretty cool effect, and you can see we've got several songs that we are looping through here. I can stop, I can start up again, reverse, and forward. And so this is a pretty complete audio solution, and it's very powerful, but it's still simple to use. So let me talk you through what we've done with this. I'm gonna stop this for now. And what I want to talk about is kind of how we set this up. So how do I approach this project? We started to approach the project by saying, what do we want to make? So we want to make kind of a Winamp style audio player with a visualizer on it. So we know we need to be able to load several audio tracks. We need to have the visualizer, and we also need some sort of controls. So we want to make sure when we load in a file, we automatically play one. We want to make sure that when that song is done playing, that we advance to the next song. And then we also want to have some user input. So to help explain the flow here, I've put together this chart so we can kind of walk through it really quickly. So the first thing we're going to do is we're going to load all of our audio files. Once the file is loaded, we're going to test and see if that is the first file that's loaded. And if it is, great. We're going to set the current track and start playing it. If it's not, if there's already a track playing, we're not going to take an action. We just mark it as ready so that it can be played later, but we don't want a second track to start playing while the first track is already playing. So that's the first branch of logic where we control the audio. When we're playing the track, if the song ends, we're going to go to the next track. And the next thing we have to do is we're going to go to the next track and say, are you ready? Have you loaded? Was there an error in download? If you're not ready, we're going to skip that track and go to the next one and test that one and see if that one's ready. If it is, we set that as the new current track, we play the track, and then we keep going from there. Now, if there's user input at some point during the track playing, the user input will take precedence and say, okay, there's been user input. The user input, for example, hit stop. So we will go into the stop and we'll wait, and we won't change the current track because we want to stay on the track that was stopped. And then when they hit play, it'll go back to playing, and we keep the same track. If they hit next or last, we test to see if the next or last track is loaded. If it is, we set that as the current track and start playing it. And if not, we will skip to the next one in sequence to test if that's ready to go. So that is kind of what we're doing. Let me get out of this full screen and take you into the logic really quickly. So here is, this is the section where we load in all of our songs. And you see we've got the 5 songs here. And what we're doing in each one in this object is we're setting a title, an artist, a link, so that for copyright purposes, we're using songs from Ronan Weber, who is one of the members of our team. And I'm also using some songs from bensound.com, which are royalty-free, free to download songs that you can find at bensound.com. Very cool. So we want to make sure we have this information to go with it. And you see that is what's scrolling here on the information panel. And we always want to set our ready states when we load when we first set up the object to false. So we have to say, once the track is loaded, we change that to ready. And the way we do that is this next section here where we load the sound. So when we load the sound, we can give it a name. This is the link to the song. And then we have a callback. And so let me move this over so you can see. So we have this little callback function here. And then basically what we're doing is we're saying, okay, now that the song is loaded, the callback says, mark my track as ready. So we've set the ready from false to true. And then we go to this track ready function. The two things to note here is that I have loop and autoplay set to false because we don't want the song to loop. We want it to stop so we get that on end callback. And we don't want it to autoplay either because we don't know which one is going to load first. So each one of these songs is a different size, and depending on the network traffic or any number of reasons why one song might load faster than the other, we don't want to set any of them to autoplay. We want to control that ourselves. So the way we control that is, let me go to track ready. And in track ready here, this is a really quick little function. We check to see if our parameter, our variable music playing is true or false. If it's false, that means that no music has started playing yet. And that's great because then that means that track that first called track ready is the first track. And so with it false, we will start looping through the tracks. And basically what we want to do is look for the first one that we find that's ready. And the reason we're doing it this way is because as the first one is called, as the first track is loaded and it calls track ready for the first time, there may have been a slight delay and two tracks mark themselves as ready at the same time, and they might be in a different order. Because we really don't care which song plays first, I left this as a loop through the tracks, and the first one that you find that's ready, start playing it. That way we have a little bit of a fallback. Just again, it's we just want the first track that's ready. So we set the current track to whichever one we find is ready, and then we do this ready check. And so the ready check is it is a fallback for also making sure that our textures are loaded. So the texture load might be taking a little longer than the song to load. So we don't want to make take away the loading screen and show the scene and start playing the audio until we know we've got all of our textures loaded as well. So this ready check is to check for both textures and for the songs. So the first thing it's going to do is look through our textures that we've loaded. Again, the textures also have a ready check on them and see if they are marked as ready. And if we find any of them are marked false, we return. And then we wait for the next time the ready check is called, whether by a texture or by a song. So if we get through and we see, yep, all the textures are ready, then we go through and look for a track that's ready to play. So again, we've had one of the tracks say, yes, I'm ready to play. And we've had all of our textures say, yep, we're ready. You can hide the loading UI so that our loading spinner goes away. We set the current track and then we toggle track. And so then we'll set music playing to true. So then that way we know a song has already gone through. It's the first song and we don't ever have to do that check again. And then you'll see, we'll talk about in the next video, the play animation function here, which is the thing that's playing all of the animations on the labels in the UI. So then the next thing we would do is go to this toggle track. And the toggle track is a little bit more involved, this function here. And the reason for that is because we have a couple of different ways to control. I can either control by hitting the buttons, so I can play or stop or hit the next or previous. I can also use the space bar to play or stop. Or I can use the arrow keys to go next and previous and autoplay. So because we have the dual input systems here, the toggle track will look for either an argument of track and button. If there's no track passed, that means that we don't know what track we're passing because we've already, this is what happens when you hit play or stop. So we're not going to pass a new track. We're just going to pass an undefined for track. And then that way we will just rely on whatever the current track was set at. For button, that means I've actually clicked a button. And if I don't click a button because I've pressed a key, we're just sending an undefined for the button. And so basically, you'll see a little bit of a console spew here so that you can actually, as you're playing this, if you open the console, you can see what button was pressed and then what the current track is playing and the kind of sequence there. So you can kind of follow along with the logic as you're clicking input. So if we get the undefined, you'll see we're sending some input of spacebar to the console. Otherwise, we're going to send button. This part is the meat of playing and stopping. So if we go in and we see that the button is undefined, meaning that we pressed a key, or that the button equals stop, button name equals stop, then we are going to check to see which audio track is playing, because again, we don't necessarily know which one is playing. So we're going to look for it. And that is a nice fallback so that I don't get out of sequence. I'm not passing the wrong variable and trying to stop the wrong track. I just look for which one is playing. And then the one that's playing is the one that we stop. And that way we never get out of sequence. So we look for the one that's playing. We make sure it's the current track again. And then we hit audio stop. And then we wait and say, okay, it stopped. Now we will wait until you give us further instructions. If the button is undefined and or the button name is play, then it goes through and takes the current track that we've been assigning all along and says, okay, go ahead and play that one. Now, the reason we're checking button undefined both times is because the spacebar is a toggle. So if there's no songs playing and you hit spacebar, it will play the current track. If there are songs playing and you hit spacebar, it stops the current track. So basically what it's saying is it's going to check for here for undefined. And then if I go through and I find audio playing, then I know I'm going to stop. Otherwise, if I go through and I don't find audio playing, then I'm going to play. So that's what we're doing there. And then the other part of this is, the first part was if the track is undefined, meaning we're using a button for stop or play or spacebar. Otherwise, if we're doing next or previous, then we're going to pass a track. And so if the track is passed, then we're just going to say, okay, great, we've got that new track. I'm going to change the current track to the one that you passed to me and then play that audio. So that is kind of the cycle that we go through. The only other part to look at here would be the update, the change track section here. So this is a little bit of logic that says we want to make sure that when we go to the next track, it is either we pass true to go to the next track or false to go to the last track. And the important thing here is that we stop the audio. So the first thing we want to do is make sure we stop whatever's playing and then change to the next track so that we have a clean slate. We're not playing a second track while the previous track was playing. And then there's a little bit of logic in next and previous that says what happens when I get to the end of the list to start over from the beginning, or if I'm going backwards and I get to the beginning of the list, I have to start over from the end. So that is kind of like the whole loop for music. And it's not super complicated, but we do have a few states that we have to manage as we're playing through. So now that we've seen kind of like how we run the music, now I want to kind of quickly talk about how we do the visualizer. So the visualizer is pretty interesting because what we've got here is, let me start this one playing. And then if I hit the V key here, you'll see this is a little analyzer that we have in our scene. And let me scroll to where the analyzer is. Should be right here. So this guy here sets up the analyzer for audio. It's just a few lines. And basically all we're doing is we're creating an analyzer, and then we're giving it an amplitude, which is the height of the bars. We're giving it the FFT size, which the FFT size says how many bars we will actually end up with here. If we could push this really, really high and go to like 4K or 8K, and it would be a really smooth transition of a lot of different colors. I wanted just 16 bars, and the way FFT size works is whatever number you put in here, you get half that many bars that to track the levels on. And then the smoothing is how much jitter is in the line. So the higher the smoothing, let me just even change that here to, let's say 0.9, and then hit run. And let me get one playing here and hit V to bring it back. Now you can see they just don't hop very much because the smoothing is pretty high, so it doesn't have as much energy to it. The smoothing just kind of equalizes out all of the noise. So because I wanted ours to be a little bit more jumpy, I'm going to put this back to 0.5 and hit run. And then you can see when I bring it back, there's a lot more noise in it, which feels a little bit more like an old school equalizer, which was what we're going for. So basically what we're doing is we're taking each one of these bands of value, and every frame we are passing it to the shader. So down here, basically we're taking the frequencies from the visualizer and then passing them to an array that is talking with the node material here. So then each one of those bands is feeding a value into the node material. So the next part of this whole process was figuring out how do we do this, and this is all done in one texture on one quad. So we're not passing 16 textures, each with its own level in it. It's just one texture and one quad and one node material. So let me take you over to, we're going to go into Substance Designer. And Substance Designer is what I use to create our texture. So in fact, let me go back to this and hit stop here. Okay, so as we've got the texture that we're working with, I have a couple of things that we have to make sure we build into it. The first is we've got 16 rows of 20 lights. And so what I did is I'm just using some simple shapes. Let me show you, kind of walk you through it really quickly. We're just creating a box. We're going to put a blur on the box, and then we're going to do a histogram scan so that we can sharpen it out, and that gives us our little round corners, which is a nice little trick. We're throwing it into a tile node so that we get all the tiling that we want. And then I scaled it down a little bit. And then to get the little highlight, which looks like this. So when the light isn't on, we get this little highlight on the plastic light. I did something very similar where I started with a square, created a negative in the center of it, and then used an angle to multiply together to give myself kind of this gradient in the shape. And then I did the same trick of blur and then histogram scan to round out and sharpen everything, and then tile node. And then basically what I'm doing is I'm channel packing these. So in the red channel, we have this grid of lights. In the green channel, we have the reflections on the plastic light bulb itself. And then the last two channels, we have to have some way to let you know where in the grid you are from left to right. And we also have to know how high up the lights are going, so from bottom to top. So the last two channels, the green channel has a gradient in it that is a vertical gradient, and the alpha channel has a horizontal gradient. And basically, once we have all those things, we have everything that we need to make the visualizer. So let me go back to our playground, and I'm going to quickly show you the finished node material. It's going to look a bit complex, but it's really not that complex. What you're seeing is the same action done 16 times. So basically, it looks really daunting, but the nice thing about it is that we're doing a very simple operation 16 times here, a very simple operation 16 times, and then we're combining them 16 times before we pass them into the final. And what that does is that allows us to control which lights are going to be on and what color they're going to be. So let me close this down for a second, and I'm going to pop over to our clean node material. This is just a node material editor, and I've loaded in our texture, and I want to show you the process that I'm going through for each row of lights. And so the best way to do this is, let's look at the blue channel, for example. And this is just our gradient, our horizontal gradient. And so the easiest way to start to look at this is we know we've got 16 lights, and I want to be able to isolate out a white strip in each of the positions of the lights. And so the easiest way to start doing that is if I pull up here to our color management and grab a posterized node, and we'll drop that in value and pull out steps. And we know we have 16 columns of lights. And so I'm going to put 16 in for our value. And then let me pipe this into the RGB out. And then you'll see what happens is basically we shift this gradient into 16 blocks of gray values. And so that's a really nice way to start it out. It makes it very easy for the next step. And so the next step is we're going to take a couple of nodes. And the step node basically says, I have a value, and we're going to put this posterize into both the values. And then the value says, I'm going to compare the value that I have with a float. And if it's less than the float, it's black. If it's greater than the float, it's white. And so basically we're turning our gradient into just black and white. And so let me do this. We'll make these sliders just to make it a little bit more convenient for us. And I'm not doing a lot of cleanup on this node tree. If I was going to do that, I would name our nodes. I would make this a constant because this is never going to change. These would become constants because those would never change. But I just want to quickly show you what we're doing. So let me just pipe this one in. And so you can see it's all white because our float is 0. And the ramp goes from 0 to 1. So basically everything breaks at 0 and becomes white. But if I start taking this value up, you can see what happens is now we've got a black bar that is anything below 0.31 is going to be black, and everything above 0.31 is going to be white. So if I had just done it without the posterize, I'll show you the difference here. You'll see how it moves pretty smoothly. And then with posterize in here, as I move this, you see it kind of snaps. And then what's happening though is that's helping us align with the vertical lights that we want. So the posterize actually does a really nice job for us because we don't have to be super precise in the number, and the posterize will correct for it. So now let me take this one and we'll just put this a little bit higher than 0.22. So let's say 0.35. Okay. So we've got 0.36 and 0.22. And what I'm going to do with this one is, you can see if I plug this into the end, it's the same black and white, it's just a little bit further over. But what I want to do with this guy is I'm going to come down to our math and take a 1- here and slide that in. And then basically we've reversed the two colors. So then if I take a multiply node and give myself a little room here, we'll take the 1- into the right and this step into the left, and when we pull that out, now we've got a nice little bar. And so I can come in and make sure that it's down to just one of those posterized strips of gray. So that's basically how I'm isolating out just one of these bars, and then we would multiply that bar with the red channel, for example. So if I'm going to apply just that row of lights, we would take this guy and then multiply it with the red channel, which is, as you remember, is our light mask. And so then when I put these together, now I have all of our lights. And so obviously we've got a little bit of fine tuning to do here to get them to line up. But basically we would see, okay, here's all the lights, and that gives us the ability to isolate each one. And then from there, we would also add in this other gradient, which would say, okay, from bottom to top, this shows you how high up we go in the light. And that is being driven by the data from the visualizer. So I know that's probably a little bit, we're going a little fast on that, but once you start digging into this, it should be pretty self-explanatory. So let me open this guy up again, and you can see basically this is what we had done. We'd done our steps and our 1 minus and our multiplies. That's the thing we just showed. And then on the other end, we did the posterize again, and then the 1 minus in steps. And then we're multiplying everything together and adding the columns together so that we ended up with being able to drive each and every one of these guys with a specific value. So once we're able to, let me take this guy and drive it into the end just so you can see what we end up with, which is all black right now, unfortunately. I wasn't thinking about that. We aren't passing the data in. But you can see here, this is all of the unlit lights. And so we have both the light bulb and then the little reflection here. And the way we're doing our colors is we're using a gradient node. And so basically what we did is we said, okay, we're going from 0 to 0.25 as red, and then 0.26 to 0.5 as yellow, and 0.5 on up is green. And so basically, and that maps up with the gradient that we're using. And so if I was going to pump this guy in, you would see, okay, this is how the lights roll up in color. So that's how we're getting our color breaks, is just with this simple gradient node that we're scaling into the whole thing. And then this is the glow mask. And I've talked about glow mask in the past with how to take the glow layer and add in this glow mask in enemies so that we can get a glow right on a node material. And so it's the exact same process as before. We'll link that video down below in the description just in case you want to look back to it. And also I should mention that we're going to also obviously link the playground and all of the materials that you see here in the description below, so you can dig in and check it out and play around with it. And so now let me just close it back down. And so now that you've kind of seen everything, let's look at this one last time. And so we've got our, and I can get rid of our inspector here, just so everything's out of the way. You can see, again, this is our visualizer. We don't actually need to have that here because it's just, it's working in the background, and we can just turn on and off the visualization, but it doesn't do anything other than just show us what we're piping into our node material. But then basically you can see this is how we got our 16 channels of color, and then how we're handling the color and the breaks going up. We talked about how we are loading our audio and how we're controlling the audio. And so basically the whole process, like I say, it seems like a lot, but each individual piece, if you kind of break it down and look at it, the process we're doing isn't very complicated. The audio engine is pretty powerful and allows you to have a lot of control over audio tracks. So you could talk about audio like we're doing with music, or you could do audio for sound effects, or audio for any kind of user input. And so the audio engine will allow you to play and stop on user input, or however you want to run your logic. It will play multiple sounds at a time. It can loop, it can autoplay. There is one thing to note here, and let me go back to this guy for a second. We have one thing that I want to pull out, and if I can find it here, we have just a moment. Here it is right here. So there are two things to think about. When I'm working on the desktop, it's fine. We are auto playing, and Edge allows that autoplay functionality. Chrome, on the other hand, wants user input. They want the user to say, yes, we definitely want you to play audio when you come to this page. And so it'll prompt a little bar or a little button at the top that you have to click to enable audio. So for the most part, we want to make sure that when that pops up, that we recover from it. So basically what's happening is Chrome says, I'm going to pause your audio context and wait for user input. And then once they give me the user input, you have to resume your audio context. iOS also does the same thing. They will pop up every time you go to the page, even if you aren't auto-playing, which is different from Chrome. Chrome only does this if you autoplay. iOS, if you don't autoplay, anytime you do a user action, the first time you do a user action on a web page, it will pop up that same button for the user to say, yes, please play audio. So once you say, yes, I want the audio, you have to resume your audio context. So we do have to go back here and set the audio engine to add this observable. So on audio unlocked observable, we want to go back and play the current track. And the reason we're doing that is if I had set my tracks to either autoplay or loop, we normally handle that. Because I set both of them to false, I'm going in and manually saying, when we see that the audio has been unlocked, go ahead and play again. So I want to restore my audio context. That's the only other bit that might be a little tricky. And it is specifically to do with Chrome not wanting pages to autoplay music without user input, and Apple always wanting you to say, yes, please use my speakers to play whatever sound is on this web page. So other than that, that's really the only gotcha with the audio engine. And it is basically just being mindful of the restrictions that are put on your playground from other browsers. Other than that, it's very straightforward, pretty powerful. The node material, like I say, is pretty complex, but once you break it down and realize it's just doing the same thing over and over and over again, it's not that big a deal. And so hopefully this gives you a great overview of how we're starting this whole process with the audio engine. And the next time we're going to get into the control section, so we can see how we do handle the animations and handle the hover states, which again is another node material. The whole process, or the whole playground, is just 2 quads. It's only 12 vertices and 8 vertices and 12 draw calls or something like that. So it's really lightweight. I think the biggest resource hog is just downloading the song files. So hopefully you've taken away some cool tips from this. Maybe you get excited about using audio in your projects, and we can't wait to see what you do with it in the future. If you have any questions, leave it in the comments below. We'll make sure we get back to you as soon as possible. And if you like this content, give us some feedback. Like or don't like. You can subscribe to our channel so that you can get notifications about when we put out new content. We try to put out some new content every week. And we love to have you along for the ride. So I hope you have a great day and that you enjoyed this project. Take care.